Okay, so lesson 3, our one and only topic. Let's go right to our Canvas and check out our examples. Now, we've been talking about how to create equations for a line, and we use, actually, let me get a color besides black here that will stand out. So we'll use red and write down, whoops, did not select. Now that's kind of pink. Sorry to the boys. Hope you don't mind the salmon pink. All right, y equals mx plus b is the standard equation that we've used to create the equation of a line. Now my question is going to be, what do we do if we get limited information about a line? How can we use that limited information, or what limited information is enough information to create a line? So the first example we're going to talk about is what we call slope and point. And here's what I mean by that. Suppose you were told that there is a line, a mystery line, and you know that the slope is -3. And you know that there is a point on that line, which is the point 1, 3. Put a little arrow here. So the information we know, just to make sure you understand what I'm saying, is that the slope is -3, and there is a point somewhere on that line that is the point 1, 3. And that's all we know about the line. And the question is that enough information to create an equation, a y equals mx plus b equation? The second example we're going to look at is a 2 points example. And in this scenario, we would be given 2 more hints. Well, this is a different, I'm going to put a line here. These are 2 different examples. But in the second example, we're given different hints. The first is that somewhere on our mystery line is the point 1, 2, and somewhere else on our mystery line is the point 4, 5. So again, the question is this enough information to create an equation for a line? And if it is, how do we do that? Okay, let's go back to our first example, the slope and point example. So we know this is actually kind of nice, because right off the top we know one of the 2 important pieces of information. Keep in mind that our 2 important pieces of information are slope and y-intercept. If we know that information, we can easily create equations, and that's how we've been doing it in the last section. In the first example here, slope and point, we already know one of those 2 important pieces of information, which is the slope. So if my equation is y equals mx plus b, well, actually, more specifically, I already know that this equation is going to be y equals -3x plus b. So I already know the m because it was just given to me. They didn't even make me work for it. I just had to take that -3 and plug it in. So that's pretty good. We've already found the slope. Now the question is, can I find the y-intercept? We do have a point here that we know is on the line, 1, 3. But is that a y-intercept? Well, a quick graph will show us the point 1, 1, 2, 3 is right here. So is that a y-intercept point? No. I mean, it's interesting to know that it's on the graph, but that's not going to tell me what b is. I mean, that's what we want to know, and it doesn't tell us that information. So how can we use that information to our advantage? Well, we're going to be a little bit sneaky. We know that y equals -3x plus b. We have an equality here that we know is true. We also have a point which happens to be an x, y point, right? A point is an output-input pair. So I know that if I input 1 into this equation, it's supposed to output 3. Take a look at the point and see what I mean by that. If I input 1, it should output 3. So I know that this equation should, again, I'm going to use another color just so we can see the difference here. I know that if I plug in the value of 1 for x, and then, I multiply it by -3, and I add b, I should come out with an answer of 3. So the input of 1 should give me the output of 3. So that's a true statement. That's something we know because of the point. Does that help me? Well, yes, it does, because look at this equation that I've created with my information I know is true. Plugging in the xy value, I now have an equation with only one variable. It's b, and b is what we want to know, right? That's what we've been asking. We want to know, what is the y-intercept? Well, can I figure that out now? Yes, just by a simple solving of this equation. So I would say, 3 just stays the same for a moment. I'd say negative 3 times 1 is just negative 3 plus b. And then I would want to solve for b, so I'd add 3 to both sides. And I just get 6 equals b. So look at that. Just by plugging in that xy point, I have discovered what the y-intercept is. The y-intercept in this case is going to be 6. So now I can write my equation. I have all the information I need to know. I know the slope is negative 3. I know that because they told me that at the beginning. And I now know that the y-intercept is 6. And I know that because I solved for it. So how can I write my answer? I'm going to go back to the color black here for that one. We will say y equals mx plus b. We know m should be negative 3, and we know b should be 6. So the answer is y equals negative 3x plus 6. And that's the equation with the two hints, m equals negative 3 and the point 1, 3. Make sure you have all of that written. If you didn't get it all written down, pause the video for a moment and write that down as a model, because we're going to be working through several examples in class, and I want you to have this information to go back to. So if you like having kind of like a list of steps, the first thing we did was we put m into the equation. You can write that all out. I just don't have a lot of room here. The second thing we did is we plugged the point in to the equation. We solved for b, and then we just made our y equals mx plus b equation. That's basically what we did. So we plugged in m, we plugged in the point, then we solved for b, and we had our equation. Okay, now let's look at our second example, our second scenario. We have a mystery line. In this case, we also have two hints about our line, but they're different hints. In the first example, we had a slope and a point. In our second example, we just have 2 points, 1, 2, and 4, 5. Those are our two ordered pairs. That means that if I were to input 1 into my equation, I should get out 2, and if I input 4, I should get out 5. So we ask ourselves, do I know any information yet? Do I know a slope? Well, no, I don't. At least not by looking at those 2 points. Points don't directly give me slope, so I don't have the slope. Do I know the y-intercept? Well, again, if I were to plot the point 1, 2 or the point 4, 5, you would find that neither one of those are y-intercepts. So no, we don't have the y-intercept. But there's good news. Keep in mind talking about slope again, keep in mind what slope is. Remember, slope is, wanted to make that blue. Slope is rise over run. And remember, in the very first video where we talked about rise over run, or about slope, I said that we can also think of it as the change in the y variable, because the y is the rise, y is vertical, over the change in the x variable, because x is the horizontal, it's the run variable. And so that gives us a nice formula, I was going to say equation, but gives me a nice formula where the slope is always equal to the change in y, which is like y, the second y minus the first y, over the second x minus the first x. And what I mean by that is this. If I had 2 points, I could find the change in y, or I could find the rise by taking the second y and subtracting it from the first y. So if this is this is what we'll call the first point, and this is what we'll call the second point, I could find the rise of the slope here by taking 5 minus 2. And I could find the run, or the change in the x's, by taking the second x and subtracting the first x. So that's what this formula means. So let's see if we can make that formula work for us. So we say slope equals the change in y, or y2 minus y1, over x2 minus x1. We said that our second point has a y value of 5. Our first point has a y value of 2, so we'll say 5 minus 2. We want to find the change in the x's, x2 minus x1, so we look at our second point, we have a 4, and our first point we have a 1, so we say the change in the x's are 4 minus 1. What does that give us? Well, on the top that gives me 5 minus 2 is 3, and on the bottom that gives me 4 minus 1 is 3. Which it doesn't have to come out the same, it just happens to, which means that we have a slope of 3 over 3. Or maybe it would just be easier to say we have a slope of 1, right? Because 3 divided by 3 is just 1. So our slope is actually just 1. So look at that. We have our first piece of information. So that's important. We needed to know that we had what we had for a slope. So let's pause and reflect. Do we have enough information now to write our equation, y equals mx plus b? Well, we do have the m, but we still don't have the b. How can we find the b? Well, good news for us is that, think about our first example. How do we find the b? Well, we had a slope. We put it into the equation. We had a point. We put that into the equation. That left us with an equation for b, and we were able to solve and figure out what the y-intercept was using the slope and the point as our information to get that. Well, do we have that same information over here in our 2 points example? We didn't when we started, but we do now. We have, following our 1, 2, 3, 4 bullet points, we have an m. We have 2 points, so we can choose either one. I always recommend choosing the one with the smaller numbers because why not? That just makes our life a little easier. And then we can solve for b. So here's how we're going to do that. We have the equation y equals now 1x plus b, right? Because we substituted 1 for m. By the way, if you have 1x, you could just write that as y equals x plus b. Doesn't matter. You could write it as y equals 1x, or you could just write it as x because it's the same thing. Now we can plug in a point. I'm going to choose the first one, but you might be interested to know that it doesn't matter. I could choose the second one too. It really, either one should give me the same answer. So the x value of that point is 1. So what that means is if I input 1, I should get an output of 2. Let's write that into the equation as input 1, output 2. Now we still don't know what b is, but now can we figure it out? We plugged in the x, we plugged in the y. Can we figure out what b is? We can by just subtracting 1. We're just solving for b. It will give us a solution of b equals 1. So now, can we fill out our y equals mx plus b equation? Y equals mx plus b. What is the value of m? It's just 1. And what's the value of b? Just 1. And that is our answer. Although we often, like I said, we drop the 1 in front of the x because it's kind of redundant. We don't really need to say that we're multiplying by 1. Multiplying by 1, just everything stays the same. So our answer is y equals x plus 1. Again, make sure that you write that into your notebook because this is going to be a model for how we solve things in class. I also want you to compare the slope and point to the 2 points examples. They're very, very similar. The slope and point is a little bit easier because there's one step you don't have to do, and that is you don't have to find the slope, you already know it. In the 2 points example, everything is the same except that you have to find the slope by yourself using the formula for slope, which is y2 minus y1 over x2 minus x1. So that is it. There is no second topic in this section, and so you should be able to just close up your notebook now, make sure you put it in your bag, and that you're ready for class tomorrow, and we'll take it from there.